Hello, my name is Donnelly and this is the Ascent podcast, the show where we interview students and professionals in the field of STEM subjects, that's science, technology, engineering and maths. This is kindly brought to you by Semester Learning. Today's guest is Paul Fryer, an NVQ manager and assessor at Semester Learning.
So Paul, tell me a little bit about yourself.
Right, let's see. Left school, started an apprenticeship, didn't get on with that. So after the first year, left that and basically then moved and then joined the Air Force. Worked in the Air Force for 12 years. I was mainly working on Harrier jump jets. Spent most of my time in Germany, did 8 years in Germany, working on first line and on major servicing of the Harriers. Ended up becoming an expert on their hydraulic systems and the mechanical systems of the Harrier. So I used to go all over the place to fix things and give people advice. After the 12 years, decided that the RAF was cutting back on people then. So basically I was a number and I was got rid of. So I then went to work for an automotive company called Daewoo, which at the time was a Korean company who had more money than sense. And they try to do things better for cheaper, which, as everybody knows, doesn't work. But they did learn, and they did get some good products in the end. And I was working there as a test engineer, and I started out cutting up cars to see how they was made, and moved all the way on to doing full testing of vehicles on a platform that simulated road situations, road low data as it was called then. Once I'd finished with that, the company folded to a certain extent, so everybody was got rid of. From there I went into contracting. I was contracting for automotive companies and for aerospace companies, normal things, Rolls-Royce and things like that, working on their new style of engines and things like that, just make components of. So I worked my way up to a senior test engineer, and I took a full-time job doing actuators for helicopters, military helicopters, for the rotor blades and the tail rotor, the actuators for them.
Did you do any big projects during that time?
Big projects. Well, the big projects was that for doing the testing of the actuators, I was actually the boss of it. So I was the senior test engineer. I was given a space in the workshop, a large space, and then we had to build from the ground up everything. So the hydraulic system to run the rigs, the electronic systems, the control systems, the cooling systems, everything. That was my job, and I had a small team of about 7 people. 2 of them were permanent staff, and the rest of them were contractors. So so that's what we did there, and I worked there for a couple of years until sadly I had an industrial accident that put me out of work for a few years. So at the end of that, once I'd actually got myself back together again, I then decided that going contracting was my best option. it meant I had more flexibility, much more money, which was important at the time. And I got to go to many different companies to work. I did for the Osprey, which is the helicopter that takes off like a helicopter. Sorry, an aeroplane that takes off like a helicopter and then rotates its pods. I was the one that actually tested the in-flight refueling probe, and I did the full testing on that before it was actually fitted to the Ospreys. So, and I've done other ones. I've done in-flight refueling pods, full testing on those. So I've done a variety of stuff. I also worked as a contractor on military vehicles for the American market for redeveloping a Jeep to take the place of a Humvee, because they wanted to replace the Humvees. And I worked for a company that was developing a new vehicle for that, based on a Jeep, an American Jeep, and I was in charge of all the testing on that. Yeah, I've also done armored vehicles and things like that. So it's a lot of variety in what I've done.
Yeah. I mean, that's kind of the good thing about working in engineering is, there's always different projects, different companies. There's such a wide variety of things which you can work in.
Yeah, it is. It's basically, if you start out in engineering, it doesn't mean you have to stay in that actual one position. You can, as soon as you've got the basic knowledge of engineering, you can actually change that. My CV says I can change my knowledge to any situation, any engineering situation. And when you think about it, anything that's to do with engineering is always the same. It's always mechanical components, electrical components, hydraulic components, air components, and they all work in the same way. So therefore, it doesn't make any difference if you're working on parts of a jet engine or you're working on parts of a vacuum cleaner.
Yeah.
They all have to work by the same principles. So that's why once you've got the basic knowledge, you can then change it to whichever one you want to do.
Yeah.
Yeah. So, and that's basically what I did. I tried going into management for a while. I was a manager we was developing a new London taxi, and because of the requirements for a London taxi, it has to have a very tight turning circle. So it's got to be able to turn in a road between two lanes.
I think it's something, isn't it, like 8 meters?
Yeah, it's
7 meters, something like
ridiculous, and it's the company I was working for. They'd come up with this idea on how to get it to actually turn the steering that far using parts from different vehicles and then putting them together so you could actually get the full extent that you needed it to turn. And that was originally for Nissan, until Nissan got into trouble and they decided to pull out of the project. So that's how it goes. That's how your life can go with things like that. You can either go for the easy thing and pick a company that you know is going to be there forever and stick with the same job forever. That's fine if that's what you want to do.
Yeah.
But I preferred to try different things, and that's why for me contracting was a very good way of doing it. And then I got to the point where my health was deteriorating, and so I thought, okay, so if I can't do the actual job anymore. How about I use the knowledge I've got and pass that on to the next generation of engineers?
Yeah.
So that's why I went and worked for a college as an assessor, engineering, purely on engineering side. So that's what I did. And I went to work for the college, and I was out on the road the whole time, doing thousands of miles a month, and going from one company to another to do observations and assessments and reviews for students. And in the end, the mileage just got too much. And then this job come up of working for Semester, and it being all online, I can do all the good stuff from my college job and not have any of the bad stuff.
Yeah.
So yeah, so I've now got the perfect situation where I can pass on the knowledge I've got, use it to its best, and help the future engineers. So
Yeah. Yeah.
that's where I'm at the moment.
Okay, perfect. So moving swiftly to the next thing is with the experience which you've had for with teaching students, what kind of career tips would you give to those students who want to go into the engineering industry, like work experience, courses, education, any kind of hands-on experience?
Right. A lot of people won't like me saying this. It's I'm a very strong believer in hands-on. An engineer is only as good as his working hands.
Yeah.
So if you want to do an engineering career, in my opinion, this is purely my opinion. This isn't one of the companies or anybody else. It's just mine. Is that the best way to do it is if you leave school or college, yeah, go and do an apprenticeship if you can,
Yeah.
or just go and get working for a company, starting at the bottom, sweeping the floors and cleaning up after everybody else, and then you get taken on to actually watch people, and then you learn the job, and then once you've got to a point where you've got a certain amount of knowledge, if you want to take that job further, then go and get a degree.
Yeah.
For me, a degree isn't something that you should do straight from college, because you're not getting the hands-on that you actually need to understand how things work. Without
Yeah.
getting your hands dirty, you have no idea how something works, how it's put together. So it's like if you go and you want to become a CAD jockey, a designer. You go and work on a CAD system, computer aided design, and it's no good going to do that if you don't know how the thing works and how people are going to look after it, how they're going to service it. Because you can design it in a perfect package so it looks good and works, but nobody can actually get to actually fix it or work on it.
Yeah.
So you've got to have both sides of it. You've got to have, for any job in engineering, you've got to have the hands-on as well as the other side of engineering, the design side, the testing side, and things like that. You've got to have the knowledge to start with. Basic knowledge, how to use a hammer, how to use spanners, things like that. Yeah.
Yeah,
So
yeah, no, I totally agree. I think the kind of foundations of what you learn kind of gives you that brick and mortar of what you can do later on. But I think learning hands-on experience gives you the it gives that additional knowledge of working on projects, and gaining the skills which you need for actually to put on your CV.
Yeah, it is. It's when you go for a job, yes, education is good. You've got to be educated. You've got to, yes, it's fine saying you've got a degree. But if you've got no hands-on to support that degree, then I'm afraid that as far as a lot of people are concerned, it means you're very good at learning.
Yeah.
I've come across too many people who've come out of university who think they know it all, and then you give them a couple of spanners and they go, well, what are these? So I know it sounds basic, but I have had it before. It's the basics, though. That's why the apprenticeships are so much better, because they teach you the hands-on stuff, the very basic, how to file a bit of metal into a perfect square, how to drill holes and how to be safe about how you do things. So, yeah, I'm a big advocate for the apprenticeships over the university degrees. Saying that, the degree does have its purpose. You need to do, nowadays, you've got to do a degree to progress. So if you're happy with where you are, and that's as far as you want to go, it was always the case with me, was I was not allowed to go into management in the aerospace business because I did not have a degree. Yeah. But I was too old in my eyes at that point to want to go and do a degree, just purely and simply to move up to management, which I found out later I didn't enjoy. So, if you start at the bottom, you'll always be a better manager. So, and that's my personal opinion. Again, you need that grounding to know. You've got to know how it works before you can go and tell people how you want it done. Okay.
Yeah.
Right.
Perfect. Okay. So, would you say that there's a positive transition in your experience from traditional in-person education to online learning?
Right. I had a discussion with somebody. He was a potential assessor not too long ago, and I had to argue the point that it is possible to do a qualification purely online. The person was insistent that how could you do an observation online? Well, we're doing one now. Because we're doing a face-to-face at the moment, that can be an observation. I could actually watch you doing your work. It can be also shown with pictures. It can also be shown with short videos. So the actual learning online is possible, and it's very feasible nowadays. Right.
Yeah.
Then you've got the other side of it also. The company doesn't have to send their employee to college. Yeah. And you're set to the college's timetable. So that when the college says, right, this week you're going to be learning how to use a mill. Yeah. Whereas if you're actually doing everything from the company can turn around to you and say, right, we've got a meal free for the next couple of days. You might as well come and learn how to use that, and they use their own people to teach them the way the company wants it done on the company's products.
Yeah.
So it's a lot more usable knowledge for the actual person. So therefore, doing like an apprenticeship online is much better because you're actually tailoring what the company wants you to do to what you learn.
Yeah.
So you're learning the facilities. Okay, you could say the drawback is, well, you're not learning everything that a college could teach you. But the college only teaches you the very basics. Whereas working in industry, you'd actually find out the proper way of doing things.
Yeah.
The safe way of doing things. Safety is always an extremely important point. And as everybody knows, health and safety nowadays is getting to the point where it can be restrictive. But the thing is that health and safety is there to stop you injuring yourself, to make sure you do it so that you're not going to harm yourself or others. Yeah. So there are things that the college goes very much on health and safety, and because we as assessors are very heavy on health and safety, we can see from pictures and videos whether somebody is doing something safely, and doing it correct. Okay, so therefore it works the same for doing MVQs. They're all done, like someone said to me, how the hell can you do a welding qualification online? Well, if I was actually there doing an observation on them, as you would do with a college, you've got to arrange to go there on the day that they're doing a job that's relevant, which can be very difficult to arrange.
Yeah.
Whereas online, what they do is you don't need to go and see them. They take lots of videos, they take lots of pictures, and you can see each weld. You can see the detail of the weld, how they're welding, by what angle they've got the torch and everything, from the pictures and from the videos. It's just like being there. So that's why on those sort of things we insist that the pictures and the videos show us close-ups, so we can see the quality of the weld, the penetration of the weld, and it works. It works. We don't just rely on ourselves. We also get them, because most welders have to have their work signed off by a competent person within the company, because they're not going to want to let out welding that's no good. So therefore, we use those as well. When they say they've checked it and they're happy with it, that makes us happier. Yeah, but we still do our own checks.
Yeah.
Okay, so that's why the online side of learning it will eventually, I think personally, take over from going to a college, purely and simply because online, the learner and the company control the timeline. Yeah. A college,
it's tailored to more their flexibility and their learning habits and behavior.
Yeah, exactly. It's if you've got somebody who likes to take their time doing something, then it's fine. You're given, like for an example, an MVQ, you're given a year to do it. Yeah. I have people that sign up to do a NVQ And they've finished it in 2 months, purely and simply because they've had the jobs to write up. They've answered all the questions they need to answer. And they've done it all correctly. Yeah. If you think about it logically, if someone's got to do, say, 5, 6 job reports, and they've got to answer 6 sets of questions. Now, think of it logically. In a week, that person might do 5, 6, 10 different jobs. If he was to gather the pictures and take notes, do the videos, he could then sit there the whole weekend, write all the job reports, go through and answer all the questions, and he could be finished the course in a week. But of course, there has to be a limit, because it's also you do need a bit of time for the assessor to get to know the person's work. So we say the minimum to finish an MVQ is 2 to 3 months, so that we've got time for them to do it and for us to do it, because we still have to mark it all and make sure we're doing it correct. So there's also the point that at the moment, because this is fairly new, the actual full online stuff, online learning, it's the governing bodies haven't quite got their heads round that people can do it a lot quicker than they can in college. They're not set to the college timetable, as in start in September and you finish in June, July, whatever. You start with one of our courses. The instant you pay for it, the instant you're put on the system, you start the course. If you then want to put all the work in and get it done within a couple of months, fine. If you want to spread that time over the full year, also fine. It doesn't make any difference. It's up to you how quickly you want to do it. So that's the best bit about it. That's the best bit about it. We have loads of people who come on and say, right, my company said I've got to have this qualification, otherwise I can't get my pay rise. Now, they don't want to be waiting a year. So they will really push, and they'll be finished within 3 months so they can get their pay rise. Whereas other people, they get told by their company to do it, and they will take the full 12 months. It's just the way it works. Okay?
Yeah. Okay, perfect. So where would you say how things are going within the engineering industry in the future? Would you say that there's more of a transition towards green energy, a transition to renewable sources and things like that?
Right. There's definitely a transition going on from traditional engineering, what I would say traditional engineering, to first off a throwaway society, which means that whereas before you would, if you had a pump break, you'd take the pump off, you'd take it to pieces, you'd find out what was wrong, you'd try and fix it. If you can fix it, you'd fix it and put it back in again. Nowadays, you've got more of the throwaway culture where once it's broke, throw it away and put a new one in.
Yeah.
Or you'll get the thing where people don't actually do the fixing at the company that's using the item. It will be sent away to somebody else to fix it. And you just fit a new reconditioned one that you've already got. So it's that is, you're losing a lot of the old engineering skills for actually repairing things and making things usable again.
I
Simple.
totally agree. I
Yeah.
think, even in the domestic situations, I think a lot of kind of DIY things which you'd normally do, they tend to be left more towards doing the professionals, or like you said, the throwaway culture
Yeah.
which people tend to have these days.
Yeah, it's a shame because the I had when I worked for the college, I had one person who worked at a cardboard box manufacturing company. Now, all their machines were 50 odd years old. And of course, there weren't any spares for them anymore. So this bloke was contracted to fix their machines, and him and his grandfather had a workshop with all the old type equipment, old lathes and old mills, the really big stuff. So you can put something like a 12-foot shaft onto a lathe to actually turn it up and make new parts. And they would take the rollers and things like that where they'd worn, and they would then put them onto the lathe, and they would then actually weld up to make a new surface, and then turn that surface back down to the correct diameter, and then reinstall the bits. Nowadays, no chance of that happening. It's worn, throw it in the bin, put a new one on. But it's only because of that. In that instance, you can't get the spares, and the company cannot afford to replace their machines. You're talking multi-million-pound machines. So there is a lot of that that's being lost. But then a lot of it is now changing to the renewables. So a lot of people are now becoming involved, employed in the renewables field. There, you're still keeping a lot of the general engineering knowledge and things like that, but as of course, you're not going to be using the same techniques that we used in the olden days, if you want to say it that way. You've got more modern techniques using composite materials and special materials, ones that are specifically made for the new engineering. Yeah. When you're talking about the wind turbines, for instance, I have a few learners that are actually working on wind farms. So they're actually servicing the actual wind turbines. They're also on the boats that actually look after the wind turbines, and they obviously then have to look after the boats as well. So you've got people doing that, and the general idea of the actual renewable energies and going into renewables as a job also has the knock-on effect of making other jobs available for people putting solar panels up, people putting wind generators up on farms and things like that, people going off grid. So that it's nowadays a way of saving, especially with all the electricity prices, the gas prices, and all that rocketing at the moment. There are a lot of advantages, and there's a lot more people out there learning how to do these things. So, yeah. But if we want to get on to a different subject of whether they are the correct solutions is another question. So, right. So, but as I say, the renewables is something that I'm very interested in, especially wind generation, electricity generation by wind turbine and solar energy. I have my own experiments running at home for a wind turbine and for a couple of solar panels. I've been running them for a few years to see what they're capable of doing.
Have you had any success with them?
No. And the reason why is because I started out with, bought myself a 300 watt wind generator and 300 watts of solar panels. Yeah. And they were charging up 4 12-volt leisure batteries. And they was running an inverter. I had a 1,000-watt inverter and a 3,000-watt inverter. So I could run 240 volts from them. And I found that you needed a much larger system to actually get any decent benefits out of it. But when I started doing this 4 or 5 years ago, the cost was phenomenal for a little setup like that. And that was the restrictions then. But nowadays, I'm now looking at buying myself a 4 kilowatt solar array and the equipment to actually link it into the house, so it will run off the solar energy first and then off the grid if the solar energy isn't available. So yeah, and with a system like that, I will actually be putting electricity back into the grid and being paid for it, a very minimal amount, but I will be, and the system will pay for itself nowadays. That system will pay for itself within 3 years. So yeah, so nowadays renewable energies, the prices are always coming down and there's always new innovations.
You've been listening to the Ascent podcast by me, Ethan Donnelly. This has been kindly brought to you by Semester Learning.